expressing things as fractions, expressing things as percentages, right? Without a calculator, I'll show you both, right? So, what is 5 days as a fraction? Look, it's 5/20, right? However, if it wanted it as a percentage, we'd need the bottom number to be 100. So we'd be timesing that by 5 to make it 100. Therefore, times the top by 5. So it's 25 out of 100, which is 25%. Now, not all of these are possible to do that with, okay? In fact, most of them are not. So just don't even bother doing these. You just write in 25 out of 35. However, these, I do want them as percentages, but you start by putting them as fractions. Do not use a calculator for these. So if I was doing this one, for example, 27 out of 50, but as a percentage, I'd want to know what that is out of 100. What do I need to do? Times the top and bottom by 2, and that'll tell me what that is. Now, with a calculator, okay, basically what that means is you're not going to be able to make the bottom number 100. It's not going to be something like 10 or 20 or 50, something that will quite easily become 100. So put it into your calculator like that and just literally times it by 100, and that does the same job, and that'll tell you what percent that is, okay? So I'll do that quickly for you now. So into my calculator, 54 over, or you divide, it doesn't matter which one, by 129, equals, make sure you press equals, and then times 100, and I get to one decimal place 41.9, if I round it correctly to one decimal place, okay? Something similar, but with a bit of shapes. What is the volume of B as a percentage? In other words, as a fraction. We don't do percentages, we do fractions. So B is 4 times 4 times 5. That's how you do the volume of a cuboid even, which is 80. And A is 5 times 5 times 5, which is 125. So the fraction is 80 out of 125. But to change it to a percentage, because we've got a calculator, rather than trying to make the bottom number 100, which is what we do if we didn't, we'll do that here and get 64%. Okay, then we've got a page of all pages here. I mean, next topic, number 8. I hope yours doesn't, I'm going to check the booklet. I hope yours doesn't photocopy like this with titles on the wrong page. No, yours looks better than mine. Okay. I'm going to do completely different ones to what are here so that you can have a go with these yourselves, okay? I'm going to do things like 0.6 times 0.3. My pen is starting to go a bit weird, right? 3 6s are 18. How many numbers after the point here? 1. How many after the point here? 1. That's 2 in total. Jump back 2 and put the point in. Lovely. Whereas if I had 0.4 times 0.2, 4 2s are 8. But I still want 2 numbers after the point, so I'm going to have to jump and put a 0 in there that I can jump over before I put the point there, so that I've got my 2 there. So that's a little bit harder. Or even harder than that, if I put 0.25 times 0.04, for example. We've got something very similar there, I suppose. 4 25s are 100. Okay, but I need 1, 2, 3, 4 numbers after the point. 2 there and 2 there. If I jump back 1, 2, 3, I'm going to need an extra 0 to make it 4 digits. Then put the point and the extra 0 in there. So try those. Okay, working with fractions. If we're adding or taking away, then the bottom numbers need to be the same. So to make the bottom numbers the same, I would times that by 3 and times that by 3. Then I take away the top. 9 take away 1 is 8, but the bottom number doesn't change. That is the same. If we were adding those, right, we would just add the 9 and the 1 instead of taking them away, same thing. However, if we're timesing, then we times the tops and times the bottom. So 5 15s are 75. Okay, and the hardest one of them all, let's pick something like 1 over 7 divided by 5 over 6. Okay, then it's keep, change, flip, like KFC, but it's KCF. Keep the first one the same, change the divide to a times, and flip the second fraction round. Flip that. So 5 over 6 becomes 6 over 5. And then you can times the tops and times the bottoms like you did there. So have a go with those. Okay. Working with improper fractions. Or mixed numbers, like sometimes these are called. Okay. If I wanted to change that to what's called an improper fraction, I basically times those together, right, which is 21, 7 times 3, and then I add the 2 on. So 21 add 2, this would be 23 over 7. Now, more interestingly than that, let's pick one that you can have a try of these. Let's go for something like 1 1/4 plus 3 7/8. Okay. Here, I would add the big numbers, 4, right? Then I would add the fractions. So that will need to become 8. So it's like that one. But if I times that by 2, I've also got to times that by 2. 2 plus 7 is 9. So I've added the big numbers, and then I've added the fractions to get 9 over 8. But the problem with 9 over 8 is, right, now it'd be great if you can get that far, fantastic. But the problem with 9 over 8 is it's improper. It's an improper fraction. It's top heavy. Okay. What you can do here is go, okay, if I was cutting a pizza into 8 slices and I had 9 slices of pizza, I've got more than one pizza because there's only 8 slices in one pizza. So how many 8s go into 9? Right? 8 goes into 9 one full time with a remainder of 1. So instead of saying I've got 9 slices of pizza when a pizza's cut into 8, I've actually got 1 full pizza and another 1 slice out of 8, another 1/8. Okay. So basically then, ladies and gents, that 1 can add on to, I know I'm rushing here, and if this doesn't make sense, let me know. Okay. It becomes, so we add that on. So instead of writing 4 and 9 over 8, that's the same as 5 and 1/8, which is a nicer answer. Now we know how to do these, guys. Change that so this out of 100. So it's a percentage. Change that one so it's out of 100. Change that into a percentage. It's not 3%, it's 30%. Change that into a percentage so it's 29%. Once they're all percentages, put them in order. And the word of is times, right? So what is a half times a half? A half of a half. Again, if we're multiplying, 1 times 1 is 1, and 2 times 2 is 4. Ratio, not saying anything about it. Let's pick one, add them. Add 1 plus 3 is 4. Divide 24 divided by 4 equals 6. And multiply. 6 times 1 is your first answer, and 6 times 3 is your second answer. Now, look at the wording. Divide or share. In these cases, we are told the full amount. This is what I'm sharing. £24, 35 sweets. That's what I'm sharing, okay? Now I'm looking at some past paper questions where that is not the case, right? Now there's numbers missing here, all right? Yeah, there's numbers missing here. You need to know something here. You need to know that there are 24 socks in total. My apologies. I just noticed that question is incomplete. Now, something like this, though, the rest of these. James has some apples and some oranges. The ratios of apples to oranges is 2 to 5. So the ratios of apples to oranges is 2 to 5. Now look at the difference. It's really, really important. You can spot the difference in a ratio question. He has 15 oranges. Not he is sharing this amount of fruit. He ends up with, that is one of our answers. So we'll have to go, okay, 2 to 5. how many 5s make 15? He's had 5 oranges 3 times. But if I times that by 3, I've also got to times that by 3, and it becomes 6. Same here. The ratio is 5 to 3, but instead of saying we're sharing 120 sweets, we end up with 120 lemons, and we have to work out how many strawberries. So same with the last one. Read the question. If it says we end up with this many lemons, we end up with this many boys, then that's how to do that. There's people at my door. Right, okay. Upper and lower bounds, let's get this done. Okay. So basically, if something is to the nearest centimetre, we need to add and take away 0.5. What the heck is this one? That's complete nonsense. I'm so sorry. So the upper bound would be 60.5, and the lower bound here would be 59.5. That is nonsense. That should be 96.3. Change that, guys, in your booklets if you've got them next to you, and change it to 97. Very much the same as there. That's if it's the nearest centimetre, nearest kilogram, nearest hour. It's 0.5s. But if it's the nearest 10, we need to add on and take away 5. So the upper bound would be 80 add 5, and the lower bound would be 80 take away 5. And if it's to the nearest 5, then we're adding and taking away 2.5. Okay? I think the most common one, though, is this type of one where we're adding and taking away 0.5 when it's to the nearest 1 centimetre or nearest 1 kilogram. Okay, now using that, you can do this. I thought this one was interesting, though. Okay, a population is 85 to the nearest 5. So what some people have gone is, well, the lowest there would be 82.5 because we've taken away half of 5, which is 2.5. However, because we're talking about people rather than kilograms or centimeters, you can't have 82.5 people, right? So circle the lowest value. Well, 82 would round down to 80. So actually here, 83 would round up to 85, not 8, even though the answer technically is 82.5. It's just because it's people. The other two, there isn't that problem. That's the bell in school. Here, ladies and gents, find the greatest possible length of A. Give your answer in millimeters. So A is that. So in other words, what's the upper bound of that? All to the nearest millimeter. So 40.5. Give the greatest possible value of B. B is 2 of those, but both at their upper bound as well. So you're not using 25 at 25. You're doing 25.5 plus 25.5 and so on. And you can have a look through those. And finally, Venn diagrams. Okay. Again, I'm just making a video. Okay. Let's put some numbers in here. You can try some of the other ones. Yeah, let's have a look at this. So set A is the multiples of 3. So here we're putting numbers in here. Set B is the multiples of 4. So 6 is a multiple of 3. It goes in there. 7 isn't in the 3 or the 4 times table. 8 is in the 4 times table. 9 is in the 3 times table. 10 is in neither. 11 is in neither. 12 is in both. So it goes in the middle. It's in the 3 and the 4 times table, and so on. Okay, so if it's in both, it's in the middle, just the 3s over there, just the 4s over there. And then there's a probability question. What is the probability that a number selected at random is from this universal set is a multiple of 3, but not a multiple of 4? So basically, how many numbers are going to be in here? Well, the only numbers that are going to be in here are 6, 9, 15, and 18, which is 4 numbers out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I believe, if I make a mistake, my apologies, that the probability of getting a number that's in the 3 times table, but not in the 4 times table, is 4 out of 13. And finally, here we go. Right, this is just putting big numbers in now. So there's 30 people altogether. 12 say they can sing both songs. 1 minute, I'm done, miss. Last question. Sorry, guys, I'll come back. I'll finish this last question and we'll let you regret. 18 say they can sing Bread of Heaven. Now, that does not mean that 18 go there, because if I put 18 there, I now have 30 people that can sing Bread of Heaven. So I need to take that 12 away from that 18 and put 6 there. Okay, 5 say they can't sing either song, so they go outside. So 18 sing Bread of Heaven, 12 at 6. 12 can sing both. 5 sing neither. Missing number. How am I getting it? Well, if I'd read, I know that there's 30 people altogether, and at the moment I've only got 23 on there. So 7